Let's get started by configuring our project settings. We'll update the viewport width, height, and windowed setting. We'll also set the background of the environment to match that of a Pong table. Now let's add the nodes to the project. We'll start with the left paddle. Followed by the right paddle. I really like that you can put mathematical equations in these cells, and Godot figures it out for you. Now let's add the ball. Let's make sure everything is center aligned vertically. Now we're going to add labels for the scores. Player 1's score is going to be left aligned, while Player 2's score will be right aligned. Now we're going to set up our input map. We'll start off by setting up Player 1's controls. Followed by Player 2's controls. Let's code up some logic for the left paddle. We'll have to listen to some of our events that we set up in the input map. We'll move the paddle by how much time has passed based on which button is clicked. Let's restrict where the paddle could go on the screen. We're going to need the window height in order to achieve this. I tried to use min-max here, but clamp ended up being a much cleaner solution. I set up a speed variable so I can easily change the speed of everything in the game, and put it into a globals file. I set up this file to be autoloaded. Now let's copy the code from the left paddle to the right paddle and start with the ball's logic. We're going to use a velocity variable in order to track the movement of the ball and update it every frame. Let's detect the collision of the ball with the top and bottom of the screen. Whenever it hits the top or bottom of the screen, we want to reverse the velocity. Now let's detect when the ball has entered a goal. When we do make a score, we need to reset the ball's position. As well as reverse its velocity. Let's make sure we update the left and right labels whenever somebody scores. I originally wanted to use an event-based system for this, but I couldn't quite figure it out, so I just called the functions directly. Now we need to convert the score to a string. Next, we're going to add collision detection. We need to add a collision shape 2D and an area 2D to each of our elements. They need to be sized precisely so that the collision works as expected. Let's add the collision detection to the ball now. First, we'll get a reference to the ball itself, and then to the paddle that it hit. If the ball is going in the right direction and hit a paddle, it'll bounce off the paddle. And here is our final game.